I'll put everything in order so that okay, let's take arrow and let's go for this velocity vector. Okay, there's a velocity vector. So as it moves, what happens? Even its magnitude will be constant, but the direction is going to change that one. So now let's get all the relationship between the quantities. Okay, now I'll bring that one. So there is a dr cap by dt. What do this quantity will be? So we know from mathematics r bar equal to r into r cap. So this r cap, I can write it as 1 by r dr by dt. What is dr by dt? Should be equal to r omega k cap. So r get cancelled, so we'll get omega k cap here. Then similarly, dv cap by dt should be equal to again the same formula, v equal to v into v cap. So this will be 1 by v dv cap by dt. So this should be equal to no
Sir,
dv cap by dt.
r omega I cap, sir. R omega minus I cap, sir.
No. Don't stick on to your basic.
dr bar by dt. Sir,
I'll,
dr bar by dt is v bar.
in the end you can analyze everything. Just what all I discussed, just you make observation. In the end, I'll come back. Okay, dv. This is like dr bar by dt, and as moving with a constant speed, so there won't be tangential acceleration. What all acceleration it will have, so it will be only centripetal acceleration. Okay, fine this one. So what I can write dr bar by dt, I'll write equal to r omega cap. This from omega k cap it will be. Okay, now similarly dv cap by dt, what it should be equal to? So sorry, it should be dv bar by dt. What is dv bar by dt? Speed remains constant. So what all it should have only it should be equal to centripetal acceleration. So that should be equal to an, and how it will be directed? Directed minus I cap. And in fact, further, what is an? You can write in magnitude. It will be 1 by v omega minus I cap. So this will become. These are some basic relationship between them. What is the problem?
Sir, dr bar by dt is v bar. V bar is along y-axis, so j cap.
No, that particular r is what like is a fixed quantity due to rotation. So when this r bar comes here, r bar is a vector, is a position vector. Its length will be constant. Only its direction is going to change. Due to that direction, what happen? We'll get that angular velocity will be directed along k. Then the tangential velocity which is there, okay, that one its speed will be constant. That is going to change. Okay, due to changing direction of motion, what happen? We'll get a normal acceleration. Okay, that's what we say like a dv bar by
Sir,
dt. This one. Uh,
change of radial vector will be along the tangent plane.
no. You do one thing. Look at this. Dr cap by dt. It's a unit vector which is rotating. So when a unit vector rotates here, the angular displacement will take place. No. So what is this quantity? Should be angular velocity. That's what I'm showing here. No. So in fact, dr bar by dt is what you're going to write. You mean to say, sir, why don't you write this as vi cap? Am I right? I think that's what your question.
V j caps.
Vj cap, sir, why don't you write Vj cap? So then further V, what you can write it as? like a magnitude r omega, then omega j cap will come.
R omega. Yes, sir. Omega G cap.
We don't get any angular velocity which will be directed in this way. Because see, like, why do this angular velocity is there? Because of angular displacement of this position vector.
Sir, omega is the magnitude of dr cap by dt. That is not the direction of omega. A unit radial vector is not going to change along omega direction, sir. It will change
No, no,
along v
no.
direction.
See, like, the theta, what is the direction of theta? Theta will be along z axis. Theta will,
Numerically, we are getting that magnitude as omega.
no, no, no. Actually,
Sir,
theta,
numerical will get the
That is
value as
not
omega,
omega
sir,
bar,
but
sir. That is v bar.
dr by dt, both I component and j component will be this.
no rotation of unit vector.
Both
So,
components will be there at this point.
Write in vectorial form, sir. We'll write radius vector in vectorial form and then differentiate. And the velocity vector in vectorial form and then differentiate.
see, like, this particular thing, dr cap by dt, what happened will be a vector that will be directed. So you do one thing, r cap will come here. R cap will come here. So after some time, R cap will come here. Then you take the difference, because we are going to take the difference of that one, no? Final minus initial. Okay, the time is anyway, it's a scalar quantity. Then what you mean to say, somewhere it will be somewhere here, sir, because after R bar will come here. Then final minus initial, if you take it, no. So now what will happen? The theta, what will come here? What is the direction of theta? Theta should be along z axis, no?
But dr bar by dt is v bar, sir, not omega bar.
No, here, say, I think we have to go back to the vectors. I think why you have one problem. If the unit vector rotates here like this, so then what we write, there's the final, there's the initial. So then it will be how it will be directed. So this will be, I'll write R2 bar, R1 bar. In fact, R1 equal to R2. So I wanted R2 bar minus R1 bar. That is delta R bar. So this will be R1, R2 for R2 bar minus R1 bar is needed. So minus R1 bar. Okay, look at this one now. So minus R1 bar, this R2 bar. So the resultant will come somewhere here like this. So that is what delta R bar. This delta R bar is what will be responsible for that small arc length. And what is delta R by delta T? That should be equal to V, no, again.
Yes, sir. Then v is not perpendicular to the plane. V is inside the plane only. So it will have I
Yeah,
cap
yes,
and J cap components.
it's one. Actually, what will happen? This delta R further, what you're going to write it as, there's a length here. This arc length. This S equal to, you're going to write R theta. This is going to vary now. D theta by dt. R is constant. This d theta by dt is what will become omega.
Sir, we are doing in vectors, so we can't write
Yeah,
like
yeah.
that.
That is what the final equation will end up like this. If you think, because this in what action, this d theta by dt will measure, you'll measure along z axis. So therefore, I should bring the k cap here. This is what the kinematics of circular motion is what brought here. The only thing is what happened, we have got stuck somewhere to relate it to this one only. This delta, okay, I'll agree, very fine. What is this arc length? What is arc length equal to radius into angular displacement? How you measure angular displacement? Perpendicular to that. From there, the direction for omega will come. This is a basic concept. Okay, we are stopping here only. What we wanted, we just wanted to, okay, stop here only, sir. No, what I'm doing further, this arc length, I'll write r theta. Theta is varying. In what direction? That d theta will be directed. D theta will be directed along positive z axis, and that will give the direction for omega. Okay, there's a basic concept of circular motion. Okay, then you take the magnitude is asking. Okay, let's get into the problem. Okay, this will be under root of dr cap by dt omega k cap minus omega I cap. How much you'll get? Omega square,
Omega.
omega will get it under root of this one. Okay, this will be 1. That angle